In this assessment, we show the mechanism of the oxymercuration reduction, at least the first half of that reaction. The reaction is going to start with the pi bond of the alkene attacking the electrophilic mercury. At the same time, the mercury acetate bond will break, and mercury will use its d electrons to attack back to make the mercurinium ion. We can show that mercurinium ion forming on either side, since the question asks us to only show one isomer forming. So we end up with that as our mercurinium ion. At this point, water is going to attack at the most substituted carbon of the mercurinium ion, pushing the electrons in the carbon-mercury bond back onto mercury. Note that when that water adds, since the mercury is in the front, water will add from the back. And so we can show that kind of anti-addition by indicating that our new water molecule is here. Going back, we have our mercury still attached at the primary carbon, and let's get the phenyl group drawn in. Now, when water attacked, it brought along its proton, so water can come in and remove that proton to generate the alcohol. That only leaves the final step, for which the mechanism is probably not super important and is also not well understood and rather complicated, so we won't show the mechanism of step 2. All we'll do is put an arrow here and up and say that that is step 2, where sodium borohydride reduces that carbon-mercury bond and replaces it with a hydrogen.